Hello everyone, it's Cyanel and today we will see what architectural choices I have made for this computer and why. So, first, as I said in the previous video, this computer is pistonless. Why I have decided to build a computer fully pistonless? First, it's because piston can change with Minecraft version, so it's not a reliable component. Also, it's very interesting to use only repeaters, redstone dust and redstone torches to build the computer, because in fact you don't need other components. We use some comparator for data storage, but it's to save space and speed. Then I've decided to build a quad-core computer because it's interesting to deal with synchronization of each core and also the connection with the main bus. Of course, with quad-core you can run algorithm in parallel, so it's interesting in logic point of view. Also, you need to choose the architecture of your computer, the number of bits of value you want. In general, we use powers of 2, so it can be 2, 4, 8, 16, 32, and so on and so on. Of course, a 2-bit computer is not really interesting. You can build a 4-bit computer. It can be good for starting, but you can go from 0 to 15, so you can't do calculation on 3 digits, for example, and it's easy to update the 4-bit architecture to a 8-bit architecture. That's why I use 8-bit. Also, if you want to go over 8-bit, you have another problem. The problem is the signal length. When you need to release the signal from a memory, for example, like here, you have to release the signal at the same time. If you do more than 8 bits, you have more than 16 length signal here, so you need to repeat this signal. Then you have data that is not synchronized. You can deal with some data bus not in one layer. You can, for example, build the other bus here. Then you can release with only 15 lengths, but it's more difficult to build an architecture like this. So 8 bits is good because you have the number 0 to 255, and it's easy to wire all things without any delay between each line, each bit. Then you have to choose what type of signal you want in your computer. For this computer, I use only 2 tick pulses. Why? It's because with 1 tick, of course, torches can activate under certain circumstances, but it can burn out with some blinking 1 tick pulses, so it's not reliable. Also, 2 tick is the minimal amount of delay you need to pass through any logic component. The last thing is that the memory I use in a lot of parts of the computer is this type of memory. So you have one memory here. So you can see the torches lock here. You have the input and the output. As you can see, the output is locked with these torches. And when you activate and release the data from the memory, you reset at the same time this memory, then 2 tick after, the reset is effective on this line. So you have always a 2-tick signal. It's really easy to generate it with this type of memory. Another thing I want in my computer is no blinking output. So for example, this adder outputs the right value in a synchronized way. You don't have any blinking result. That way, you always have a clean value in the data bus, so you can't write wrong data in storage and activate wrong things at a wrong moment. It's really important, I think, to have a clean computer. The last thing I want in this computer is a versatile main bus and peripherals management. That way you can expand as you want the main bus and connect any peripherals to it. For example, I have prepared another type of data storage to try some sorting algorithm, sorting lists. Also, you can connect a keyboard. I have prepared one, but it's really awful to connect it with a single data cable, so I don't have ads yet. And you can, for example, connect a graphic card and choose some operation to do with those 5 bits. So you can do a lot of things with peripherals. So that's it for this short video. In the next one we will see some hardware. Thanks to you for your support on the previous one, and see you soon. Bye!